Today is a review on simplifying rational expressions, multiplying and dividing, and adding and subtracting. So let's take a look at some of the types of problems you'll end up seeing on tonight's homework. Here's one where we end up having to simplify this expression. So the first thing you want to do is factor. In order to simplify, you've got to have factors. Factors are numbers that are being multiplied together to make a larger number. And so that's what we see here, is we see an expression that we want to factor. See, there's no factors here. Everything's being added or subtracted. And so you just can't cancel out your x squares like this. You have to have factors. So we look at the top of the fraction and draw two sets of parentheses because there's no common factors between any of these terms. And it factors to an x plus 5 and an x minus 3. And then down below, we've got ourselves a difference of squares that's going to factor to binomials. And it factors to an x minus 3 and an x plus 3. And so what we're able to do is cancel out some common factors. X minus 3's are going to cancel out, leaving us with that x plus 5 over an x plus 3. And that would be our answer. Well, taking a look at the next one, it's a multiplication problem. Now notice there are no addition signs anywhere to be seen, no subtraction signs between any of these coefficients or variables. And so here's where we get to use the commutative property. So you cannot do that on a problem like this or like this because you see the subtraction and addition signs between the terms. But here we have none. So we can go ahead and just bring the terms together, like 2 and 20, bring those numbers together. Now, typically, I don't multiply them because I look for canceling that can occur with the terms that are on the bottom of the fraction. Here I have 4x's and another 4x's, make 8x's all together. And I have 1y and 5y's, make 6y's. Down below, I've got a 5 and a 14. So typically, I look at them and I see, okay, I can reduce 5 and 20, so I'll put the 5 underneath the 20. And then I count up the x's. It looks like I got 1x here and 6x's here, makes 7x's all together. And I have 2y's and 3y's, make 5y's. So now I look to see if I can cancel things. And so I can. I have a 2 and a 14 have a common factor of 2. So I'll do the reducing. I'm left with 7 and 1 on top. 5 goes into the 24 times, and this becomes a 1. And then these 7x's cancel out 7x's on top, leaving me with just 1x left on top. 5y's cancel out 5y's up top, and that leaves me just 1y on top. So we go ahead and rewrite it with what's left over. I've got a 4, that's what we have here, and then an x and a y. Left on top, down below, just have a 7, that's it. And so there is our answer. Well, the next one's a division problem. So with the division, you always want to take the reciprocal. So I'm going to change it to multiplication. And I'm going to rewrite this. Now I'm going to factor it as I go. So x squared minus x minus 12 ends up factoring to an x minus 4 and an x plus 3. Numbers need to multiply to make the negative 12 and subtract to make negative 1. Here I see a difference of squares. So whenever you have a binomial, the only way it will factor is if it is a difference of 2 squares. So x squared is a perfect square, 16 is a perfect square. So it's going to factor to an x plus 4 and an x minus 4. Now I'm multiplying by the reciprocal. So notice that I'm going to end up putting the denominator on top. So I'm going to go ahead and factor this. And it factors again as a different, not a difference of squares, but just as a 2 binomials. And it factors to an x plus 4 and an x minus 3. The numbers need to multiply to make negative 12, but this time they had to add to make positive 1. Now the denominator, notice that it goes down below. I took the reciprocal. So I'm going to factor that, and it factors to an x plus 2 and an x plus 1. So now I go ahead and look to see if I can cancel anything, and it looks like I've got a whole lot of nothing. Except for the x minus 4 that cancels out. Oh, I got an x plus 4 as well, so that reduces. Well, and that's about it. I just have an x plus 3 and an x minus 3 on top. So I'll go ahead and rewrite that. X plus 3 and an x minus 3. Those multiply together. And then down below, it looks like just the x plus 2 and the x plus 1. If you left the answer like this for me on the test, I would go ahead and accept that. I like it in the factored form myself. but you might end up having to multiply it if it were a multiple choice test. So this is the answer you'd also get. X squared minus 9. Down below you've got an x squared plus 2x plus 3x. 3 x's, because the 1x and the 2x make 3 x's, and then the plus 2. And that would be our answer. But if you left it in the factored form, I'd be fine with that. This is a division problem, so again, we're going to multiply by the reciprocal. And what I'll do is I'm going to take out common factors. Notice that on these problems I had two binomials. Here, I've got some common factors. Always take out common factors. So you'll see 3b goes into each of these terms. So I'm going to take out that 3b, put it on the outside of a parenthesis, do the division, see what's left over. It's a b minus 2. And so now I'll do the bottom here, same sort of thing, look for the common factor. This time we just have b squared. So we take out that b squared, put it on the outside of a parenthesis, do the division, you've got a 2b plus 3. And then we go ahead and move on to the next fraction. Again, notice that I'm putting this denominator on top. So I'm going to take out the common factor first, take out a 4. And so it's going on top now, so 4 on the outside, I'm left with a 2b plus 3. And then now this numerator is going down below. It's becoming the denominator because I took its reciprocal. So I'm going to take out the common factor of 2. So I put the 2 on the outside, do the division, and what's left over is a b minus 2. Now I'm ready to cancel. So again, you think of this as like one big fraction here, and you look to see what cancels out. I see a b minus 2 cancels, 2b plus 3 cancels, and I have a 2 goes into 4 2 times. I have 1b here is going to cancel out this 1b, so I'm just left with b to the first power down below. So let's rewrite what we have left over. Looks like a 3 times by 2, so that makes 6. And then down below it's just a b. That's it. So 6 over b is the answer. Well, the next problem is a subtraction problem. So you'll see some addition, some subtraction. Some of them have the same denominator, and I wanted to do one that did not. So first thing I would do with a subtraction problem like this, I'm going to change it to addition and take the opposite of that second term. Next thing I'm going to do is I see a common factor here. I always like to factor it as much as I can or cancel things out. So I see this 2 goes into this 2. And since they're being multiplied, see how this 2 is being multiplied by x, you can cancel that. So I'm left with negative 1 over x. So let me rewrite what I've got. I've got a 5x over x plus 1. And then now it's a plus negative 1 over x. See, this is easier to deal with because the numbers are smaller when you reduce the fraction. Now, a common mistake is people want to cancel out the x's here, but you can't do that because it's not really x on the bottom. It's 1 more than x. And speaking of that, these denominators need to be the same. So since I just can't multiply this by 1, because if I did, I'd just end up with 1x, I need to multiply it by its other denominator, the other's denominator. And so it's going to be an x plus 1 over x plus 1. This one's just going to be an x over x. So I go ahead and multiply across, and here's what I get. 5x squared over x times by x plus 1. I like to leave it in the factored form for the denominator, because this way I'll see what ends up canceling. And so I have a plus, and then I have negative x minus 1 over the x times by x plus 1. Now, when you're at this stage, don't do any factoring, don't do any canceling. You want to collect like terms because they have the same denominator. We want to write it as one fraction right now. So when I do that, I've got the 5x squared, and then I've got the negative x, the minus 1, and this is all over x times by x plus 1. Now, you can try to factor the numerator. Sometimes you will be able to, but it doesn't help you at all if it doesn't cancel the x plus 1. So what I like to do is I like to check to see if x plus 1 is one of the factors. And it might not even factor, but check and see if it does. Use x plus 1, because if it doesn't factor with an x plus 1, it doesn't even really matter whether it factors or not. You wouldn't be able to cancel it. So the next one needs to be a 5x minus 1. But it's not going to work because you see how the outside-inside terms subtract to make a 4x, not a 1x. So nope, it doesn't end up factoring, so we can say that this is our answer. Last one here is one that you'll see on the homework where you've got two different denominators, but both signs are opposite. See how it's a positive x here, negative x, negative 2, positive 2. So when you see that, you can just multiply it by negative 1 over negative 1. Now when you do that, the first one stays the same, x plus 2 over x minus 2. But down below, on this next fraction, and up above, the signs switch. See, negative 1 times by 4 makes negative 4. Multiply here, we've got a x minus 2 now. See, negative 1 times negative x makes a positive x. Negative 1 times 2 makes the negative 2. So now I can go ahead and combine some like terms. So I'll add the 2 and the negative 4 together. So I have x minus 2 over, well, hey look, another x minus 2 because the denominators are the same, so I just leave it like that. Well, at this stage, here's where you can cancel. X minus 2 over x minus 2, they cancel out and just make 1. So 1 is the answer in this case. So those are some of the problems that you'll see on tonight's homework. Good luck.